Hello, good afternoon, everybody. Today we're going to talk about bringing your own identity provider in Entra ID, or BYO IDP, if you take it for short. Basically, we're going to look at OpenID Connect-based protocols and what kind of fun things we can do with those in the cloud. Before we kick off, a little bit about me. So I'm Dirk-jan from the Netherlands. I have my own company called Outsider Security, where I do a bit of a mix of research, pen testing, consulting, and training. Started that like 3 years ago, so been doing this for a couple while. Also, most of my research I do by writing tools. So the tool that we're going to talk about today is also part of ROADtools, which is my Entra ID red team, blue team framework. And I also like to talk about these tools or about my research. It's my third time at XeveCon, second time as a speaker. If you missed my talk 2 years ago, that was probably because it was 9 a.m. and you were still in bed after the pirate ship, so shame on you. Don't do that tomorrow. Tomorrow Dominic has the honor of having the 9 a.m. talk. And this time everyone's here, so that's great. What are we going to talk about? So first we're going to talk about what is OIDC, or what is OpenID Connect, and why do we actually care. Then we're going to look at different implementations that all use this protocol. So first we're going to look at federated credentials, then we're going to look at external authentication methods, then we're going to look at conditional access custom controls, which is very similar to external authentication methods. And then we're going to look at how you can actually detect the things that we're going to talk about from the red team point of view first. So we'll cover the red point first, and then after we'll also talk about some blue team perspectives and how you can detect these kind of things. So first of all, why are we talking about OpenID Connect? Personally, I think that OpenID Connect is a little bit less popular, because most of the time when we're talking about Entra, we're talking about Microsoft 365, then people care about getting access tokens, because access tokens are tokens that we can send to APIs, we can get data with that, you can get a token for Teams, for example, and exfiltrate all the stuff. So most of the time people only care about these access tokens. And how these access tokens are actually validated, what protocols are used behind that, all the OAuth implementation, it's a little dry, theoretical, and no one really cares about that. However, ID tokens are quite interesting. ID tokens are used quite commonly. In fact, whenever you're using single sign-on, you may be using ID tokens. And the difference basically is that access tokens provide authorization, so they tell you what you're allowed to access, whereas ID tokens are for authentication. So it purely authenticates you as a user against a specific OAuth client, for example. So Entra ID uses this quite a lot. In fact, whenever you're doing single sign-on with a web-based app that trusts Entra, you're kind of doing like OpenID Connect. So in the technical side, OpenID Connect is based on OAuth, so it's an extension of OAuth basically. If we talk about OAuth, then we talk about the authorization server. In this case, it's Entra ID, formerly known as Azure AD. I'm going to call it Entra. And that's going to issue ID tokens, and the ID tokens can be sent to the resource service. You get such an ID token by asking for the OpenID scope. So if you look at authentication flows, you see the OpenID scope, then it's doing OpenID Connect. And basically the difference between ID tokens and access tokens is that access tokens are intended for a resource provider, like an API, so you can send access tokens to Graph, you can send them to the Outlook API, Exchange API, these kind of things. And ID tokens are intended to authenticate the user towards the client, so that the client or the application that you're using actually knows who you are. So that's basically how you use it during single sign-on. However, there's also quite a few protocols that use these OpenID Connect flows basically to perform different kind of authentications. And the first use case we're going to look at is federated credentials, which is also something that's based on OpenID Connect. So if we have an application in Entra, then we need to authenticate that application usually, and that's why we configure application credentials. So maybe this looks familiar to you. This is the Azure portal. You go to applications in there, and then you can configure secrets or certificates. And there's 3 possibilities. There's client secrets, there's certificates, and there's this federated credentials thing. Now, most of the time people use client secrets or certificates. That's like what you see most commonly. Client secrets, then you use the client secret itself to authenticate, which is like a password for the app. If you use certificates instead, then it's going to create a signed assertion that it uses to authenticate. So it's not using the private key directly itself to authenticate, but it's signing something. And then we also have the third case, which is federated credentials. And this essentially allows another identity provider to authenticate as this application. So with federated credentials, we're kind of avoiding the whole secret thing. So you don't need to store a secret anymore. You don't need to store a private key somewhere. You just authorize somebody else to authenticate to your app. So that's basically the concept of federation, federated credentials. Technically, federation means that you establish some kind of trust relationship between an application, and that's going to trust like an identity provider, so that the identity provider can do single sign-on. You have one place where you authenticate, that's the identity provider, and then it sends things to the service provider or the resource provider. So this is quite a well-known concept in enterprise context, like Entra ID is technically also doing this. Often applications that you connect to Entra, they trust Entra to do the authentication. So this is the technical definition of federation. However, I usually like to simplify this a little bit, so we're going to ignore this. Basically, what federation is making something else responsible to do the authentication, and also trusting that they actually do that properly. Basically, that's the important bit about federation. So the best known example of that is probably Active Directory Federation Services, or ADFS, which is doing this exact thing. And there's also like an emphasis on this trust part, because if you have ADFS, you're using that for your authentication, which means if your ADFS is compromised, people can mess with that whole authentication flow, pretend to be anybody, and that's basically just how that works, because that's what you do. You trust that service to make the authentication decisions, to handle that properly, to perform the task correctly that you use it to. So basically, federation means outsourcing things to somebody else. And in the case of federated credentials, we are adding like additional identity provider to the authentication flow. So if I have federated credentials, there's this identity provider. We'll call it not Entra in this case. And that's going to issue tokens. Those tokens are being sent to Entra. And Entra is then going to trust that identity provider and give us tokens for the actual application. So we put an identity provider kind of in front of our identity provider, because both are identity providers in this case, which makes it a little bit confusing. But basically, we have Entra and we have another identity provider we authorize. Now, how do you configure such a thing, or how does this look? If we look at applications, then you have various options, and in this case, it's for GitHub Actions. So one of the things with federated credentials is that you can authorize another identity provider, in this case, GitHub, to authenticate to your application. So if you configure this, then you can automatically let that application authenticate in like your build pipeline. You don't need to manage secrets. It can just automatically get tokens as long as it runs in that specific build pipeline that you specify. Now, I don't really care about configuring all of this, but you can scope this to branches, repositories, etc. The one that's a bit more interesting for us is this custom provider, basically, because this allows us to create any other identity provider to perform the same flows, basically. So this is identical to GitHub, except that GitHub here is a template, and it has a specific format that it will always use, and we can basically create our own provider as well, and then we have to do the things manually. So we can basically trust any identity provider that we create to actually authenticate to this application. So if we configure an identity provider, we do need to follow a specific authentication flow. And that's going to be the client credentials flow, or client credentials grant flow, which is essentially the way that applications authenticate, that applications get tokens. And if you have federated authentication, then basically what Entra wants is a signed client assertion, and its client assertion basically comes from the other identity provider, and that identity provider issues you a token. That token gets sent to Entra, and Entra exchanges that for an Entra-signed token. So the protocol level is just exchanging one token for another token. If we look at how that's actually implemented, then basically we authenticate to Entra, and we send this federated assertion. So if we are using GitHub, then this assertion is something that's issued by GitHub. GitHub like says, okay, this identity is running in this build pipeline. Entra has a configuration for GitHub. It's configured to trust GitHub for this specific app. And Entra is basically going to do OpenID Connect discovery, and that has a specific endpoint. So it's going to look at the OpenID configuration, and it's going to tell Entra, okay, these are my keys, and these are the public keys that GitHub, for example, has. Entra is going to fetch these public keys. It's going to use these keys to validate the signature on the assertion. And if the signature is valid, then that token must have been issued by the other identity provider that we configured. So that means that we're going to issue a token. So there's no secrets here. Well, GitHub has secrets. But basically, we don't need to store any secrets in our build pipeline. It's just the fact that it's running in that build pipeline, which is certified by GitHub, for example, that makes the build pipeline have the ability to get tokens for this app. Now, the only things that we need to implement to actually create a custom authentication provider are these two parts. So we need to have this OpenID configuration, this discovery document, and we have to have the document that hosts the keys. That's not super complicated. Essentially, at the minimum, you need to have 2 JSON documents that you host, one with the discovery information, one with the keys. And that's why I decided to create a very minimalistic OpenID Connect implementation. It's part of ROADtools called roadoidc. And basically, you can host that on Azure Blob Storage, because you just need 2 JSON files in the case of Federated Credentials. And then you can basically trust that identity provider, which is not a real identity provider, but it works anyway. Or you can host it as an Azure App Service, which makes it a little bit more flexible, because then it can dynamically run code, which is something that's relevant in the follow-up attacks that we see. And if you configure this, then you can also request tokens with ROADtools, which is the Road Token Exchange tool, which is also part of the ROADtools framework. So how does it look? Basically, I have an application. I configure my federated credentials. I call it roadoidc, or something that looks a little bit less suspicious. And that's configured on my app. And then I can use the federated app auth command to authenticate to that app. So I say this is my client ID of the app I want to authenticate to. I'm signing that assertion with this certificate. That certificate is generated by roadoidc. This is the subject, so that's the name of the app, the tenant, and the issuer, which is in this case just these JSON documents hosted on the Azure Blob Storage. And I want a token for graph.microsoft.com, and you see that this works. So it's using this client secret, and whichever app is configured to trust this fake identity provider, I can authenticate to with ROADtools. Now, what is the point of this, or why is there? What is this advantage of this over client secrets and certificates? Mostly OPSEC purposes, because it's quite a well-known technique in Entra to basically add credentials to service principals, to abuse the privileges that they may have, or add credentials to apps. And there's a lot of built-in queries for Sentinel, for example, that will monitor for the addition of new client secrets, the addition of new certificates. However, federated credentials are, first of all, quite less well-known, so you don't see them that often. And also, they leave different traces, basically, because if I add a client secret, there's 3 events. I can see that the application was updated, the service principal was updated. I don't think this actually does anything. But I also see this middle one, that a certificate or secret was added. And this one actually contains the most data. So that tells you, okay, a secret was added to an app. So a lot of detection queries, they work on either this one or this one. If I configure federated credentials, you see, first of all, that the middle event is just missing entirely. So it's not adding anything. That's technically because we're just changing the configuration of the app. We're just saying there's now another identity provider that can authenticate as this app. So we're updating the application, but of course this will modify quite a bit different properties. So it's not going to get caught by most of the detections that focus on this. If you have detections for the addition of secrets to apps, then you should also create detections for adding federated credentials to applications, because it leaves different traces, basically. The other interesting part is that federated credentials also exist on managed identities, specifically on user-managed identities. And normally, managed identities are like identities that you link to resources in Azure. And that means that on that resource, you can automatically authenticate as that managed identity. You do that with a query to like the internal metadata endpoint, then you get a token. But two of the properties of managed identities are that, one, they're linked to a resource, so you cannot authenticate without having access to that resource. And second of all, you only get like temporary tokens. You only get access tokens, which are valid for like 24 hours, but you don't get persistent long-term access to the managed identity, because that's the way that they're designed, to limit the impact. However, if we configure a federated credential, then it kind of changes, because federated credentials allow us for persistent access. We authorize an identity provider to authenticate as that managed identity at any point in time, which means we have long-term access, we can request tokens whenever we want, and it also allows us to use them outside of Azure. So we no longer need to have access to that resource that the managed identity is linked to, we can just basically use it. So for user-managed identities, it actually adds a bit of attack surface, because if you have control over the managed identity, then you can do that. All right, so if we want to configure this on managed identities, then you can go to this Federated Credentials menu, and here you see that I have configured that for the ROADtools identity provider. Two variants, actually, the dynamic one on Azure websites and the one on the blob storage. So this is very similar to the previous configuration. So that's the federated credentials approach. And if you want to learn about the exact permissions that you need to do this, I wrote a blog about this last year. So this is not new specifically, but there are a few more implementations that are also quite interesting. And one of those is the external authentication method. So external authentication methods is one of the protocols that actually use OpenID Connect. And this is a relatively new feature. It's been around for like a year. And this basically makes it possible to add external authentication providers to Entra. So if you want to use like one of these providers for your multi-factor instead of the Azure built-in methods, then you can use that with external authentication methods. And basically this uses the OpenID Connect protocol to kind of trust those parties as an identity provider for issuing like MFA claims. So not everyone has this, of course, but it is available in every tenant for configuration. And let's set up a test here. And in this case, I'm using Duo for authentication. I really like Duo because they have a free tier, so it allows me to basically try this out for free. So just all the vulnerabilities that we're talking about, that we will be talking about, have nothing to do with Duo. It's purely Microsoft's fault, because Microsoft implementation is kind of iffy. But we'll just be using Duo as an example, but this will work with any other of the providers as well. So in Duo, I can add Entra as an external authentication method, and that's going to make it possible to authenticate with Duo. So this gives me my configuration, and in Entra, I'm going to configure that as a external authentication method. So that's configured in the authentication methods policies. We just copy-paste all these configurations that we get from Duo, and then we save that authentication method. We scope that to a specific group, and then these groups of users can use Duo for multi-factor authentication. Now, as I mentioned, this is going to use OpenID Connect. And this flow, it's a little bit more complicated. So basically what happens is if a user goes to Entra, then Entra is going to prompt for the first factor of authentication. It's going to ask for a password or some other form of authentication. And then the external authentication method, if that's scoped to the user, is going to basically kick in. And Entra is then in the backend, so any red arrow here is the user flow, and any blue arrow is basically what Entra does in the backend. Entra is going to do the discovery, so it's going to look for this OpenID configuration protocol, and then it's going to redirect the user to that external authentication method identity provider. So every time we're not talking about Entra as an IDP, I'm talking about the EM IDP. In this case, it's Duo in our example. So the user is being redirected to Duo. On the endpoint that's configured in this OpenID configuration, Duo is going to prompt the user for Duo MFA in this case. And if the user completes the MFA, they're going to be sent back to Entra. It goes to the OAuth to claims provider endpoint. Then Entra will do the rest of the conditional access checks. It's going to validate that token that comes from Duo. And if everything is correct, well, actually, first it needs to fetch these keys because it needs to know like which keys are available for Duo. And if everything checks out, if the ID token was actually signed by Duo, then it will consider the user authenticated. So we see the same two documents. We see our OpenID configuration and we see our key. But we also see an extra endpoint, which is the authorized endpoint, because that's where the user will be redirected to do the external MFA. All right, so this is how the request looks. So the user gets sent to Duo. And what's included here is an ID token hint. So that's kind of like the OAuth spec. This ID token hint tells Duo which user is trying to do the MFA. So if we decode this, we find an Entra signed token. So Entra signs this, and it says, okay, well, this is the user, Duo3, trying to do Duo authentication. So Duo will do the pop-up, and basically when that succeeds, it's going to send the user back to Entra with a ID token again, so this OpenID Connect, and this token will be signed by Duo. So we see the token, the issuer of that is the Duo endpoint. We also see that the multi-factor was done. It also indicates what kind of multi-factor was done. So it's, in this case, it's proof of possession, because we prove that we had this specific device. And we also see the key that Duo used to sign this token. So this key, Entra can look that up, it can fetch the public key, it can validate the signature of this ID token, and then it knows that it was really issued by Duo and not by somebody else. All right, so if we want to create this ourselves, then we have to implement this protocol in roadoidc. And if we don't want to actually do MFA, like I don't want to create a mobile app that does MFA, I'm lazy, so I just want to always basically pass the MFA challenge. I'm just going to redirect the user back to Entra, and I'm going to tell Entra, okay, the MFA was done. We do need to deploy this on the Azure App Service, because of course this is doing some actual signing of tokens, which you cannot do on a blob storage. But then you actually have your own external authentication method, MFA provider, which doesn't actually validate anything, but it's just fun to do if you don't want to do MFA. So I'm using this for my external authentication method. I'm going to approve that with my identity provider, and it redirects me back to the Azure portal. And you know you need MFA for the Azure portal, so this passes the MFA requirements. So I did my multi-factor authentication by just talking the correct protocol. So that's just if you're lazy, or if you don't want to do MFA for the Azure portal, then you put this fake identity provider in front of that, and then Entra thinks you did MFA, but of course, in fact, you didn't really do anything, except visiting a page. There's one little issue with this. So you do technically need to have an application in your tenant if you want to use the external authentication method. Now, if you want to configure this external authentication method, then you do need to create that app. Usually it's not a problem, because configuring these methods requires quite a privileged role. So creating an app is then not going to be the issue. Technically, you can also use an existing app, because it needs to have the correct redirect URL, but we can also replace that client side, which is a little, I'm not going to talk much more about this, but basically the application requirement is not really a problem in this case. So what you can do is, if you're doing some post-exploitation and you want to bypass multi-factor authentication in a tenant, with roadoidc, we can actually basically fake the MFA. So if you have high privileged access in a tenant, then I can just add a external MFA method, and I put my users in scope that I want to laterally move to, or that I have the password for, but not the MFA. I put them in scope of my external authentication method, and then they don't need to do multi-factor anymore, because I can just put them in scope of my fake MFA method. Of course, this does require quite privileged access, so it's really more of a post-exploitation scenario. It's not that it's going to be allowed from like a low-privileged user, unless you happen to find an app with these kind of permissions. But then essentially you can just create an MFA method that exists for all the users in scope. Only limit of this is that it doesn't work with authentication strength. It is technically available in the protocol, but I don't think they have completed that integration yet. So maybe in the future it will, but currently it only works with MFA control and not with specific MFA strength. So we can just add this, and I can just scope this authentication method. I add it for all users, and that means that nobody actually needs to do MFA anymore. So I wouldn't recommend this in prod, but technically it's valid. Now, it's more interesting if the tenant is actually already using external authentication methods, because then, if they're using it legitimately, then maybe with sufficient access, we can kind of like create a backdoor. So with ADFS, this is quite well known. Like if you dump the token signing keys, you can sign your own tokens, and technically we could do the same thing here. Though I think the chance of me getting like duo signing keys is hopefully quite low, so that's not really feasible. But maybe what we can do is basically add our own keys to this protocol. So theoretically, we can do the same as before. We can just replace Duo as an MFA provider with roadoidc, and then we create our own discovery protocol, and we redirect them to roadoidc. Roadoidc is not going to do anything. It's just going to say, like, OK, MFA is now done. We go back to Entra, and then we bypass the MFA. And that works because we are now the external identity providers. We replace Duo with our own, and then we can bypass the MFA. We don't need to do Duo anymore. Of course, the problem with this is that there's now this additional domain that everybody goes to, which is not super stealthy, might be detected by some endpoint detection or some firewalls. What's more of a problem is that we now are responsible for doing all the real multi-factor authentication. If I'm doing a pen test, I don't really want that responsibility. I don't want to weaken the security of the client. We could technically redirect them to the real identity provider, but then we run into all kinds of issues. So just replacing the external provider with our fake provider is just too much risk to do in a production environment. Attackers that don't care, of course, they can do that. But maybe we can perform a different attack, and that is adding like the authentication provider in the middle. Because what we can do, theoretically, is that we configure roadoidc as an authentication provider, and then when Entra queries that, we say, well, we are we are Duo basically, and this is the issuer from Duo, and this is the authorization endpoint from Duo, and yeah, basically we're pretending to be Duo in this case. However, so basically when we pretend to be Duo, then nothing changes for the real user, because the real user will be sent to Duo or to the legit authentication provider. It's going to do the real security checks. It's going to redirect them back. But the second step is what we do is we kind of create our own collection of keys. So when Entra fetches the keys, then what we do is we fetch the keys from Duo, but we also add our own key. So we just add an additional key, which means that nothing really breaks because we just added an additional key. The real user flow will keep working. Duo still does the MFA. We just have this extra fake key, basically, that we injected into the flow. And then, if we want to use this backdoor, then we basically change the flow a little bit. So in this case, the discovery still takes place. But if we are redirected to Duo, we just change that to, instead of going to Duo, we go to roadoidc. Well, we know roadoidc doesn't care. It's just going to redirect back to the tenant, and then we completed the MFA. And this will work because we will sign the token or the ID token with our keys, and the keys are basically a combination of the real keys plus the fake keys from Duo. Now, the problem, of course, with this is that something like this is never going to work, because why would we be allowed to basically pretend to be someone else? Why would I be allowed to host the discovery thing on my domain and then say, oh yeah, the issuer is this other guy, and this is his keys, trust me. So this definitely shouldn't work. The problem, of course, is that it does work, otherwise I wouldn't be giving this talk. And why does this work? Because Microsoft. So let's do a demo with this. And actually, for some reason, PowerPoint is doing my old slides, because I made a change in this, and now there's some slides missing. So let me reopen this. Is this the new slide deck? No. All right. Well, I didn't save it. All right. So basically, let's look first at how this looks in the setup. So in this case, I'm hosting my discovery document on my own website. And basically, what we see here is that the authorization endpoint still points to the real one. So does the issuer. However, the keys, they're hosted locally. So basically, I'm saying Duo is the one that authenticates, and I'm the one that serves you the keys, which is a little weird, but it works. And if you look at the keys endpoint, you see you get both the real keys and the key from Duo. So let's go to that demo, actually. And let's make it a little bit more readable. Is fine, right? No. Free eye test here. All right, so what I'm going to do is I'm first going to do the real flow, and I'm going to use the key pass auth command of roadoidc for that, because then I don't need to fill in my credentials. It's going to do that automatically. So we authenticate with this username, enter the password, and it's going to tell us, well, we need to approve that with Duo. So we're going to continue. And then you see we go to the actual Duo website. So hopefully on my phone, it will give me a push notification. Yep. This is the push notification. We approve it. Success. And then we're authenticated. So the real user flow clearly works. Now what I'm going to do is now I'm going to proxy it through burp in this case. And I have set up my burp to basically automatically replace the redirect. So it's a little small here. Basically, before it went to the Duo website, and I'm just swapping out the URL to redirect it to roadoidc instead of the real Duo website. So we're just changing it client side, and I'm doing the change by proxying it through. And now it's going to do the exact same thing. So it's going to sign us in. It is going to enter the passwords. It's going to say, oh, you need to go to Duo. And then instead of going to Duo, it's going to roadoidc. And then we get tokens, and we didn't do any MFA. So we just injected our own keys, swapping in our own token, and then we avoid the whole MFA part. So this is really, really neat backdoor that keeps things working and allows us to bypass the multi-factor. All right. At this point, I was like, there's no way that I'm like the first one to think of this, because this is like kind of stupid from a protocol point of view. So I went and I read the actual OAuth implementation. And that has like one section on security, well, a bit longer than that, but this is the only like important part of this whole specification security-wise. And as it says here, you must check this one single thing, and this one single thing is that the issuer URL actually matches with the domain of the discovery endpoint. And if it doesn't match, you should absolutely not continue, and you should not accept this. Yeah, so that's what Microsoft just doesn't do. They are like, well, this must, yeah, let's just ignore that. We're not going to do that, because why would we actually keep the OAuth implementation as the spec says? So basically, Microsoft is not doing that. If you read the Microsoft documentation, then they also actually say that they sort of do that. Technically, they use the word should here, so it should match, which implies some theoretical thing, but this is just the Microsoft way of saying that it kind of must match, because I mean, if they don't verify the issuer either, then we would have a way bigger problem. So technically, the documentation is correct. It should match, because it's optional in this case, but they do say that it basically should be matching. And just if you're saying like, well, this is kind of obvious such a backdoor, I don't know if you noticed what I actually configured here. If you look very carefully here, the real one is actually not with a dash. So the real one is with a dot. So I just swapped it out for a dash. And if you want, you can buy this domain. It's still available. I didn't bother registering it because I don't want all kind of legal problems with me impersonating Duo and all that kind of things and brand protection. But you can just register this at least for Duo, and just changing a dot to a dash, and then you have your own external authentication method. All right, so that's external authentication methods. Then we also have this thing called custom controls in conditional access. And technically, this is sort of the same thing, because before we had external authentication methods, they had these custom controls. It's already existed for a few years, but has been like in preview indefinitely, and they already announced like, yeah, we're not going to continue with this. Doesn't mean that nobody uses it. Like companies are still using this actually in production, even though it's in preview for like 5 years already. And before we had the external authentication methods, this was basically the only way to do external MFA. Now, custom controls are configured a little differently because they will actually show up as additional grant types if you configure conditional access policies. So here I can explicitly say you need to do MFA with Duo, and the configuration is then fetched from this JSON endpoint. So this is very similar. Again, we specify a discovery URL. In this case, it's actually the real Duo. And the flow is, well, this is basically the same picture. So custom controls, they use the exact same OpenID implementation. I think it's even shared code base. Basically, they do the same thing. They fetch the OpenID configuration, redirect the user, do the checks, and then validate the ID token. So it means we can also do the exact same thing if you have custom controls, because the implementation is identical. So I can modify the custom control discovery URL, point it to my own URL, send like the fake server back as the issuer, and then sign my own tokens to also bypass custom controls. This one also doesn't need an app registration, doesn't need approved permissions on the app, so it's easier to do. And the only thing is that the response is slightly different, so the claims are different, but other than that, it's basically the same implementation. So I was like, well, this is the easiest bug ever. Like the OAuth spec explicitly says that you must do this. Microsoft does not do it. I'm just sending them the report. They'll fix this. I'll get a bounty, throw a party, something like that. Yay. Of course, in reality, it didn't quite go like this. Because I sent the report to Microsoft, actually I sent 2 reports. And I sent one describing the bug in the custom controls, and one describing the bug in the external authentication methods, because it's different features, different bugs. They closed the external authentication button bug, because that was basically a duplicate. I'm like, well, OK, if it's shared code base, I can understand that. They also closed the other bug as not a vulnerability, because, quote, admins are free to change the URL at any time, which is correct, and you need privileged access to do this, which is also correct. The only thing they talked about in the mail that in order to change this, you need to be an admin, and admins are allowed to change the configuration. They didn't like put a single word in there about OAuth, following the specs, following the mandatory implementation. So basically, it was a feature, not a bug. And also in this report, they pointed out, well, custom controls are kind of deprecated. We're not going to support them anymore. And the thing you should use is the external authentication methods. I'm like, didn't I send you a second report about this exact same bug in the external authentication methods? And the only reply I got to that was, oh, I'll pass on your comments to the team. And then quiet. So I reported this, but it actually still works. Because it was a feature, not a bug. They don't need to implement the OAuth security measures. That's too much work. So that means that this is still possible. And later I also found a potential reason why this is still possible, because I actually found that Microsoft, in their own products, they also kind of do this. So if you use Defender for Cloud apps, there's this very weird undocumented feature that you can also use that with custom controls. And there they have like a completely different discovery URL than the actual domain where the security validation takes place. So maybe they were like, well, if we change this, it will break our own products. We don't want to change the other product. So we're going to brand it a feature and call it a day. So what can obviously be improved here? Well, first of all, we could actually implement the mandatory OAuth security checks and follow the protocol. What you could also do is not use the discovery URL as a specifier, but only let the configuration specify the issuer. Because if you know the issuer, you can discover the document yourself by just appending the documented prefix. And then, of course, you don't have these weird kind of attacks because it kind of follows from the issuer where the document should be. And this is also what they use in federated credentials, because there we don't specify the discovery URL, but we specify the issuer, which kind of avoids this whole problem. So they don't know how to implement it, they just don't do it. So that's the red side. Of course, there are ways to detect this. It's a little tricky sometimes. But for the external authentication methods, we can change them in the Azure portal, in the Entra portal. And actually, this uses the Microsoft Graph REST API to change them. It does a call to the authentication methods policy and then patches the configuration. So if you have the graph activity logs, then you can at least search for the modification of the authentication methods. Of course, the graph activity logs don't record the request body, so you don't know what is changed, but at least you can know somebody changed the authentication methods in your tenant, which hopefully shouldn't be happening that often. And in the audit logs, we can actually see what is changed. That's a little tricky to find out because the format of that is a bit of a monster. And actually, we sort of managed to get a KQL query for this. I found out very recently that I absolutely hate KQL and the way that this works and doesn't work, and all the nested JSON things which appear on my screen as JSON, but it doesn't parse them as JSON, so we need to reparse them for some reason. If someone knows how to fix this or to do this better, then I'm all ears. Basically with this, and also thanks to Olaf for actually helping me out with this, we find out like, hey, this discovery URL was changed and now it's this discovery URL. So we can at least see in audit logs that it was changed. Unless you change this via the legacy API, because there's also this Azure AD craft thingy, which is going to stop working next month. Which I mean, it's still going to work next month, but Microsoft is saying that they're going to stop it next month. And what you can do there, if you use the undocumented internal API, is you can modify the policy object directly. And that doesn't really leave you any logging. It just says the policy was changed. It doesn't tell you what was changed, what the previous value was, the new value. So then it's like, oh yeah, something changed. I don't know. So this is good. If you're a red teamer, this is bad. If you're a blue teamer, so I'm going to leave this a little bit in the middle, whether you should be happy or sad about this. At least for the custom controls, it's now recorded. So this one uses the IAM API, which isn't even publicly available. I don't think there is a way to modify the custom controls over the Graph API. When I wrote the report to Microsoft, it didn't generate any useful logging. Basically, you got the same thing as here. Now they do actually record this properly, so you can see it in the audit logs. And you cannot modify this via the internal API, because modifying conditional access policies via the internal API was blocked a few years ago. So actually, the legacy feature is now harder to do stealthily than the modern feature. So this one we can also kind of detect-ish, which is again the same monstrosity of nested JSON. So we get, again, this whole long KQL query, and then we can sort of figure out that something was changed with a few ugly matches to filter out the duplicates if you have multiple of these policies. So we can see that it was changed from this to this, and then you can sort of alert on it. So to conclude, if we have federated credentials, or you can have federated credentials, everyone has federated credentials. They basically provide new ways to add credentials to apps, add credentials to manage identities, which means you need to change what you monitor for, because there's more features, which means more abuse paths. External authentication methods are, of course, interesting if you want to use an external authentication provider. But even if you don't want to use an external authentication provider, an attacker might want to configure their own external authentication provider and do their own fake MFA, which is helpful for the red team in kind of post-exploitation scenarios, pop some identities without worrying about the MFA. So make sure that if you're on the blue side, you look for these kind of backdoor keys, which shouldn't be possible protocol-wise if you implement the OWASP specification correctly, but since Microsoft doesn't, then it's a possibility. I hope they fix this at some point, but up until then, you can use this. And the roadoidc release that basically adds this like backdoor functionality. I still need to fine-tune it a little bit. We'll probably push it early next week. But the fake external MFA provider, that's already public, so you can look at it on the ROADtools GitHub. And the rest of ROADtools is also available for open source. And if you want, I also have some ROADtools stickers, which I usually forget to hand out. So if you see me want a sticker, you don't have a sticker yet, then let me know. And of course, also let me know if there's any questions in the whole 30 seconds that is left on this timer.